Okay, thank you, Praveen, for giving me this warm introduction. And since we have lost a certain amount of time in setting the PPT and everything, so I will not. I will directly jump on the topic without wasting any further time. So as you can see from the screen, I am supposed to talk on research methodology, and from the feedback received from Praveen, what I have known that the scholars are basically from the computer science and engineering department, and they are mainly working on machine learning applicable to agriculture and biomedical field. So I will initially start my lecture as a general introduction to each and every aspect of research, RM in short, I will call it. And I will try to correlate with the machine learning language research so that one can get a clear and conceptual idea of what I'm talking about. Okay, now my research will be divided into three parts. The first part will be on the basic RM, the different modules like the foundations of research, the planning and design, and the data collection. And my second part will be on the machine learning language applicable to RM. And my third section will be on a very interesting topic, and which is very much relevant in this current context, that is related to plagiarism and the use of AI. Okay, so without further wasting any more time, let's start with the first. Uh, right, right. No, not this one. Right. So, as a way to understand, this is a course of 64 credits, so that makes 60 hours as per AICT or UGC. And so it will be consisting of lectures, right? What? Yes. Huh. Hello. Should I start? Should I continue? Okay, okay. Now, the main modules of this RM are as research, designing of this research, and the data collection methods, analyzing this data collection, and lastly, as I've told you, AI in the present context, plagiarism, and intellectual property rights. These have become very much relevant in the present context. So I will touch each one of them. Now, coming to my next slide, why this RM is necessary? Now, it is necessary because it is to conduct systematic and valid research. Secondly, it is to critically evaluate the existing literature and methods, and then to create an independent research skills among the authors, and the findings, so that the findings that they get and whatever the reproducible findings that they produce, they are ethical. This is very important. And lastly, bridges the gap between theoretical concepts and practical applications. So this is why this research methodology has become so much relevant in the current context. Now, to add it in the same notion, we can also call that this develops critical analytical skills in the scholars. It provides different tools and it improves to evaluate the different aspects, methodologies, and the literature. Now, coming to the next, what is actually a research? Now, research is basically is a systematic investigation followed by which actually now first of all in a systematic investigation we need to very much be aware of why we are doing the research. So we need to identify the problem first, then it will be followed by the literature review, then the hypothesis that what we are actually trying to what is our objective, and the roadmap, the analysis of the results that we get, and lastly the conclusion. So it is, although it's a systematic investigation, it involves logical and scientific methods, and it is a kind of validation of the theories by experimental findings. Now, by definition, research is the systematic investigation undertaken to uncover new facts, principles, or theories. It focuses on how things work, exploring the relationship, and solving scientific problems. And the key attributes on that the why the research is being done or what we are getting out of it is it should be purpose driven. It shouldn't be random. As I said, it should be systematic and it should be evidence based. Now, what is the objectives of research? The same things. It should be exploratory. It shouldn't be focused on a particular aspect. It should be comprehensive in nature. It should be descriptive. It should describe the phenomena so that the one who is reading that research is able to comprehend what is going on. It should be diagnostic in nature. It should identify the problem, and it should test the hypothesis by testing the relationship and the theories. Now, what makes a good research? The same thing: systematic, logical, empirical, and the most important is this one, this ethical. This is very much important in the current context. I will tell you why. Okay. Now, there are different types of research, although you cannot classify them, but on an average, we can classify research as basic theoretical understanding research, applied research, and action-based research. So the basic research, it comes the theoretical, statistical, mathematical concepts. The applied research is based upon some practical problems that we are facing, and the action is some innovations to those by putting up new technologies like AI and machine learning, artificial neural network, etc. Now, there are two ways by which the research is being exposed. In fact, three ways. One is the quantitative one, which is based upon the numerical values, the statistical analysis. Other one, this is mainly used for mathematical and engineering research, is based upon this sort of quantitative approach. Although the qualitative approach is more for the humanities research, and there can be a mixed of both of them because in every scientific thing may not be numerically validated. So observation comes in certain aspects as well. So broadly, we can classify the approach into these three types: quantitative, qualitative, and mixed. Okay. Now, types of by time frame and method. We can also classify the research as by means of time frame. So if it is a snapshot, very instant sort of research, it is called cross-sectional. And if it is a long research over the time, it is called longitudinal. Similarly, by the methods that we can also classify the research into experimental observation and simulation. This is somewhat similar to what we have discussed right now, that is quantitative qualitative. It is somewhat similar to this. Experimental is for the quantitative, observation is for qualitative, and simulation is also for experimental, but it takes into consideration the modern computational modeling tools. Now, why why research is important? Why do we do research on the first place? First of all, it fuels innovations and discovery. All the discoveries, it is a claim that in World War II, a lot of discoveries in physics and engineering took place because it required that sort of crisis. If there was that sort of crisis, that those things had to be produced. So it requires innovation, fuels innovation and discovery, and it solves problem, and it information and policy making, and it's lastly for those who are in academic, it provides an academic growth. This is more of a practical point of view. Now, the next is in what area should we do research? How to choose the topic of the research? Now, mostly the topic is motivational. What is the motive? What is the motivation that is driving us to take the research? And then the second point that comes to, we have the skills required or the interest. Motivation is one thing, and having the skills and interest is another thing. Then is the area feasible that we are thinking, and is the facilities the place or the location that we would like to do, or the roadmap that we would like to take, is the facilities are sufficient to take up that research. And for those into academics or into PhDs, this is another factor, that is whether the supervisor having the same technical expertise is present who can guide you on that particular thing. And all these things are in fact cross-linked. They are interlinked with each other. Next is the classification. I think we have already discussed, so I'm not going into the details regarding the classifications of the research area. Now, as I've talked about supervisor in my previous slide, although this is important, but it shouldn't be that the research is of the scholar himself. It is not that the supervisor is doing the research. So there shouldn't be any spoon feeding involved as far as research should be concerned. The supervisor should have, I think that the scholar should have its own innovations and ways of approaching a problem. Okay. Now, usually in Indian perspective, for AICT and UGC, master's thesis requires at least one international publication, whereas a PhD thesis requires two international publication. And I will take two papers to discuss the way the research has been approached. And in fact, those two papers are from this university as only. For recently, it's from Chaitanya only. So this one is published in Next Nanotechnology. Right. So you can, from the topic, you can see that this is by one of the research scholars, Busharani, who recently got her PhD, and it is based upon this mixed phase copper oxide nanoparticles. Now, as initially told, there has to be some this copper oxide from the fact that copper oxide has been a semiconductor with a certain amount of band gap. Okay. Now, the copper oxide exists in different types of phases. This is cuprous oxide and this is cupric oxide. Now, those different phases, all the copper CuO, cupric oxide, where the oxidation state of copper is +2, it is a semiconductor. The properties are not similar to that if you get a cuprous oxide. Now, the oxidation state of copper again is dependent upon the inherent defects that are present while you have made this material, or it can be tuned if we induce some defects in it. Okay. So our objective was to study the effect of these inherent and induced defects in this mixed phase copper oxides. So this was the motivation behind it. And the question is, do we have the required expertise? Yes, we have the required expertise. That's why we were able to do the experiments. So the synthesis process took place and the required characterization also took place. So this is an excited characterization to find the different crystalline phases. You see that each and every phase has been meticulously found out, and analysis has taken place. It's not that only we have the experiments, we also did the analysis. That is the second requirement or the third requirement for a good research. So here analysis of the strain that has developed with the material and also the dissolution density with the variation of the doping has been analyzed. And each and every peak has been tabulated with its particular remarks. And again, you can see that the strain has been analyzed and the particle size has been analyzed, variation. So this all comes as a part of the analysis part. So first of all, it is the motivation, data collection, and then the analysis. And then we have come to a conclusion. Okay, the few more characterizations like photoluminescence were done, and we have come to a conclusion. Conclusions are very to the point conclusions here you can see. So this is one of the examples. The next example is also by the same research scholar, but here the material is a little different. Instead of copper oxide, it is tin oxide, and the applications are also different. Right. So this is the tin oxides. Now the motivation here is tin, uh, which is the static oxide. It is a good electron transfer layer in perovskite solar cell. Those who are working in solid state physics, we shall be very much aware of what I'm talking about. So this perovskite solar cell, earlier it used to be titanium dioxide. Now it has been replaced by this standing oxide SNO2. So here the oxidation state of this tin is 4, but this tin SN can also exist in two oxidation states. So if it is 2, then the material will be SNO. So there is a relationship between the crystallinity and the coagulation that is taking place during the synthesis for this uh, stannic or stannic oxide to form. So this was our motivation behind it, and again it was the data were determined from X-ray diffraction, UV vis, and PL, and then serious analysis, medical analysis, and it was also backed by microscopic techniques, scanning electron microscopy. And so this was the analysis part. So deconvolutions of the different peaks. So we have initially got this peak and they have been deconvoluted. So this all comes in the analysis part. This is finding out the band gap by tau plot from the UV vis spectra. So what I'm trying to say is that after we have obtained the raw data, the student doesn't have it. Then actually the main intellect or the effort of the research scholar starts, and the extent or the meticulousness, preciseness he puts in analyzing the data that reflects in how well the research has been done. Okay, so these were the two examples. I took these examples because they were of this university. Chaitanya, that's right. Okay, now moving further. So these are the two examples. Next is right. So I was one second. Right. So after the topic has been decided, this has been done, feasibility and everything has been done. This ethics, the question of ethics comes into the picture. Why does ethics comes into the picture? I will tell you in this next part. So this is the end of the first part where you have the basic idea, basic research idea, basics, the different types of research, and the different steps involved in doing the research. Okay. So this is end of part one. In the part two, we move on to a very important topic in the present context, that is ethics and plagiarism. Now, we have a very huge exponential rise in information technologies in the last 5 years, and it is still rising. Now, that's why this cut paste technology has also come to the picture. Scholars sometimes cut and paste different result and they put it. Now, that's why the different softwares, plagiarism software have come into the picture. So this is a thing that the research scholars must very seriously, because there are very hard implications of this. Now, what do you mean by a plagiarism? Plagiarism, by definition, it means that a wrongful appropriation and stealing and publication of another author's language, thoughts, ideas, or expressions, and this representation of them as one's own original work. This is actually the definition of plagiarism. It is considered to be academic dishonesty, and also in the case of journalism, it is also very much reliable. It is a general breach of journalistic ethics. So we need to suppose we require a data from a particular journal. The very noble way or the correct way is to use the copyrights. CC copyrights have recently earlier we used to write to the editor and the author to have permission. Now this Creative Commons copyrights have we have a separate platform, and in the next lecture I will give you the specific ideas of how to approach the Creative Commons and how to find out whether any thing we have to pay or it is free of charge. And also there is one thing called self-plagiarism. I mean, even if you're not taking the data of other authors, if you are manipulatively representing your own data, that also comes into the picture. Now I will give you very recent examples of what people have done in this plagiarism part. You can see that these two papers in these and this one are exactly the same. So these two papers are same. Only by going to the photo editor, they have made some certain changes, and they have reproduced them in two different journals with two different materials. So this was caught by the one of the editors or one of the journal softwares. Let's just see. These two are the same images, but this was published as this material, whereas the same material has been published with some photo edition as this material. So this is also a very intellectual, a very precise way of example of self-plagiarism, like this. Again, you can see these two pictures are exactly same, but this has been published with some different name, and the same picture has been published with some different name. This. So four different Same picture has been published in four different journals with four different names, four different compositions. See these two. The journals have now very highly sophisticated softwares that can detect plagiarism. Even if you do some Photoshop and all, they can be very easily detected. So I should be very much careful of this. Sometimes it even happens that they are not themselves, they are not doing it, but you should be very much careful submitting our data channel. That's why this ethics or intellectual property rights comes into the picture. Now let us have a look on the punishments that the UGC has if the thesis that they submit it should be between 1 to 10% similarity, then it is considered to be okay. And if the similarity is between 10 to 40%, it requires revision. If it is between 40 to 60%, then the student is barred for 1 year and the faculty loses annual increment. Whether it happens or not, that is not basic thing. It is has been written in the UGC norms. And if it is more than 60%, then the teacher may lose his job and the student may lose registration. That is by the Institution of Academic Integrity Panel. All right. So this has been the problem set. Okay. So this brings to the end of the second part of the lecture. And the last part of the lecture, as I've told that most of you from computer science background, the research scholars, and they're working on machine level learning. So I just wanted to relate the research methodology with the machine level learning. You can see these machine level learnings are used in healthcare, they're used in agriculture, they're used in computational materials engineering, and also they are used in some AI and artificial general intelligence that comes under nanoengineering. I'll just give you certain examples. So the flow is similar to the previous one. We have a problem. Uh, we have a data associated with that problem, and those data have got specific patterns and features. So we make a model and we validate it with experimental observations, then we interpret, and then we'll actually form the research. So this all comes into the research methodology part when machine level learning in particular is involved. One of the examples is a healthcare system. You can see how this healthcare system has been done for feature extraction, then for disease classification, and then for explainability. So these are the different research methodology steps involved. Uh, then we can have it for agriculture, machine level learning for agriculture. What we do is that we put a drone on the crop field, for example, and then we create a machine level model from the crop yield, and we ultimately we use this machine level prediction for the soil health and yield. Then machine level in computational material engineering, we can use different types of models and data. And I would request you to go to my YouTube channel where I have a separate playlist on the computational materials engineering where you can find certain few videos how this computational materials engineering or computational aspect involving artificial neural intelligence and machine level learning has been used in finding out the different materials properties. Then we have a sensor analysis. This is the age of sensors. Every time you can find, if you look around, you will find a lot of sensors. So a sensor is basically based upon detecting some sort of anomaly that is taking place. Okay, say we have a different transducers involved in it that which converts one form of energy into another form, like piezoelectric transducers, like thermoelectric. Okay, so these transducers are set in, and if there is an anomaly, like in the case of a metal detector, if you go past a metal detector, there is a change in electromagnetic waves that is taking place. So that is considered to be an anomaly. So it gives you system alert. So the machine level learning is also used in doing that, and it requires the following steps: real-time signals. This is important, and it's pre-processing. We have a pre-processing data which compares this real-time signals and finds out the anomaly and gives you the system alert. It is used in biosensing and also the Internet of Things, used in academics and in every other aspect of life today. Now, this is another thing, artificial general intelligence. After this AI, the next revolution in information technology or technology, as far as example, is artificial general intelligence, where the robots will have a say of their own. So, although it's not very far, not in very far future, but still, and then this one is for nano engineering, and this is for artificial. So, this is the AGI agent, this is the robot. Okay, so it is based upon action. It can perceive based upon the different data it has been fed, and it also believes in a reward system. Okay, so you are rewarding a robot or robotic mind based upon its action. So this is, although it's very complicated, not that simple, but still gives you the idea of how the things work in AGI research methodology. So, there is a perception which is fed to the memory, and there is a planning that is taking place which is put into action. Okay, so this I will now discuss here. Okay, so what are the key takeaways from this lecture? Key takeaways is that the research is basically a structured way of problem solving with a structured uh, roadmap. It involves the following objectives. It needs to explore the different aspects, that is literature review or that they describe. We need to select the literature review, or in other words, if we go to the experimental part, we need to do the experiments, and then we need to diagnose, then we need to analyze the experimental results, and lastly we need to conclude and we need to test. Okay, so these are different aspects of. There are some recommendations of books that can be gone through. So, if I'm giving the chance of the next lecture, I would like to talk about the research process from idea to output in my next lectures. And I will prepare a quiz for the research scholars, which will be shared to Praveen today. He can share it with you, a very a 20 marks quiz, MCQ. I request the research scholars to attempt those quiz, and I would also like to give some homework to the research scholars by on these two topics. That is, define research in your own words, not a very big, list few lines, and list three examples of applied research related to your book. And you can either send it to me in this email, or you can send it to Praveen, who can convey it. Okay, so that's it. I think that's the end of my lecture. Any questions you would like to ask? You are free to ask.